Hello again, and welcome to another lecture for CIT 130, Beginning Java. Today we're going to talk about iteration or looping, where we do some set of operations several times in order to create a result or resolve some action. This is an extremely useful tool in application development. I'm assuming that you all have some familiarity from your introduction to computer programming classes, but we're going to go over it from a Java perspective today, and we're going to look at syntax and some concepts that will help you develop your applications better. What we're going to be doing is starting from the idea of the movie ticket program that we did in the last lecture. I'm going to set our language to Java, and what we're going to do is we are going to create a new public class movie tickets, and what we are going to do is have our same main method we're used to having. Hopefully you're very comfortable with this by now. Public static void main string args. So if you remember from last time, we worked with a version of the movie tickets program where we used decision statements, if then, if else type statements for determining what price that a student should pay. I'm going to pull that example back up in the version that was uploaded to the course, which had a number of different solutions to present a few different ideas. And I'm going to borrow what we would call version 5, which is using our logical operators with our if statements. And we're going to use that in this version. But along with this, we want to add a little bit more to our idea, because one of the things you may have noticed when we worked on this before was that every time we wanted to sell a ticket, we had to rerun the application, which wasn't overall helpful in receiving the results or obtaining what we want as our end. So, as an example, when I do Java movie tickets, what you see is we put in an age like we did last time, we get a ticket price. I have to rerun the application to see another result, like how much a 12-year-old pays. So we're going to get around that so we can do more of a tally style application like you would get at a real movie theater through the example today. I'm going to start by renaming movie tickets.java to movie tickets decision, so I still have the original around for my own use, and we'll go over here. Now when we talk about looping or iterations, there are two different styles of iterations. We have what we call deterministic loops which are loops where the number of iterations are known before starting the loop. We also have non-deterministic, which are loops where the number of iterations is decided at runtime, comma, after the loop has been entered, usually due to user activity. These are the kinds of things of asking someone when they're done, or asking someone if they still have more to do. The when the loop is going to end is decided on the fly, not determined by some number of iterations that may be asked ahead of time and then used, or because we know that we're doing some calculation that we're going to multiply something 10 times, like we might do for exponential math, multiplying the number by itself the number of times of the exponent, that kind of deterministic activity. We're going to start with a deterministic viewpoint here. When we loop deterministically, we generally are figuring out how many times we have to loop before we loop. So what I'm going to do is I'm going to create a keyboard using our scanner, the same way we've been doing so far in the course. Scanner keyboard equals new scanner system.in. Remember, the scanner is in an API library that we have to import, java.util.scanner. What I want to do is I want to start by creating an integer variable called party size. And as you see below, because we copied it from the old version, we will need age as well. Now what I want to do is I want to say system.out.print. I need to prompt the user for the data we're looking for. How many persons are in your party? Then I'm going to take the data in, party size equals keyboard.nextInt. Again, we've seen this before. And that is going to take whatever comes off the keyboard as an integer. Then we will have predetermined how many times we need to check the age and determine the price. Most of the time, when we do deterministic loops, we use something called a for loop. It's called a for loop because we think of it as, for this number of times, do something. In this case, what we'll do is we'll say for int x is less for int x equals 0, x is less than party size x plus plus. This is a header, so it will have something going on inside of it. Before we talk about what's going to go inside of it, let's unpack the syntax on the line for the for loop header. The word for, as you might suspect from the coloring in here, is a reserved word. It indicates that we are going to do a for loop. The for loop has the input or arguments to the for loop has 3 sections. The first section is initialization. The second is end check. And the third is the iteration. What we're talking about here is when we're going to loop a certain number of times, we create some kind of counter, usually an integer, that will count the iterations we've done so that we know when we've finished. The middle part, which we would call the end check, or I'm going to say end check condition, is a Boolean operation that determines when we're finished. What it really indicates here is as long as this end check condition is true, we continue looping. So if we start or initialize our counter to 0, and then we go as long as the party size is less, or as long as the counter is less than the size of the party, we continue looping. So in this case, let's say you were going to the movies alone, as long as the party size is less than 1, or the counter is less than 1, because your party size is 1, as long as that counter is less than 1, you do the looping. So you would go through the loop the first time, and then we would expect that after you've gone through it, that the counter will expand to 1, and then that's no longer less than party size, so we're finished. How we increase that 0 to 1 is through the iteration piece. Now, the iteration piece has another piece of syntax here that may look new to you. So what we're doing here is plus plus, which is the increment operator, which is a unary operator that increases the value of x by 1. So how you read this is starting with an integer x at 0, as long as x is less than the size of the party, the value of this variable, party size, do what's inside this block, and then increment x. So what happens here happens before we start looping at all. Initialization occurs once before looping. The end check condition is tested before, it's important to note before each iteration. Iteration is performed after each iteration of the loop. We're using the term iteration in two ways. Every time we perform what's in the block, that's an iteration, and we iterate our counter. So in this case, when we're doing our looping for doing the pricing, what we want to do is start with having sold 0 tickets, and no matter how many people are in the party, as long as we haven't sold that many tickets already, we do what's in here. So again, thinking about it being one person, we do int x equals 0. X starts as 0. 0, because we test before looping, x is less than party size. 0 is less than 1. Then we have to test age. But in this case, we haven't gotten the age yet, right? So what we need to do is we need to do system.out.print. We need to get that age. How old is the person for this ticket? Now we do age equals keyboard dot next int. Because this is a loop, every time we come around it, we'll ask the question again. Then it will take the next thing off the keyboard as an integer, and it will replace what's in there before. Age is a variable. Its value can be replaced as we go. So that's a valuable thing to do. So every time we'll check the age, and we will get a price. Now, one of the things that we haven't done here is declare the price, double price. I'm going to initialize it. And then I am going to create another variable called total cost that we're going to use temporarily. So after we figure out the price, what we can do is we can say total cost equals total cost plus price. Total cost was initialized to 0, so the first person's ticket price will be added, and then it'll loop around again and continue until we've reached the party size. So if it were 4 people in the party, we would start with 0. 0 is less than 4. Ask them for the age, get the cost, add it in. Whatever that is, it would now be the price and total cost would be equal. We come back around. X is now 1 because after the iteration of the loop, after each, I'll put loop iteration. After the loop iteration, X is now 1 because we've increased the value of X by 1. 1 is still less than 4. We take the second person's ticket price, we add it in. So now we would have the value there. We go back, or we increment, go back to the top. Now X is 2. 2 is less than 4. So we go through, get the third person's ticket price, add it in. We now have a total cost of 3 prices added together. We increment to 3. X becomes 3. 3 is less than 4. So we check the price, add it in. We have all 4 people's prices and everything done. We increment after the loop iteration to 4. We go back to the top. 4 less than 4 is not true. It is now false. So we complete the loop and drop out, and we can do system.out.println the total cost of your tickets is $, and we're going to do this just like we did it last time, where we do total cost here, and then we can add the 0 on the end because it's never something other than 1 decimal place past the thing, so we'll get the results we want. In the next lecture, I'm going to teach you about the printf command, which allows us to format things and make them look really nice. But in the meantime, you can just use, we can just do it this way. So this will mimic what we did the last time, but now we'll be able to do it with multiple persons. One thing before I compile and run this and show you how it works is, if this confused you at all, what we are saying is we're taking the variable total cost and we are assigning to it. Remember, our single equals is an assignment operator. We are assigning to that total cost the existing value of total cost plus the value of price. Here's another place that operator precedence is meaningful. Addition, in fact, all mathematical operations take precedence over the assignment. Total cost plus price happens first, then we assign that to total cost. So we take the value that's held in total cost, we add price into it, then we assign it to total cost, replacing the value that we just pulled from it. Let's save it. This will be movie tickets.java. And we can go out and recompile movie tickets. Java C movie tickets.java. Java movie tickets. So if we go with, we are going to do a 6-person party to do essentially the tests that we did in the last lecture. So we say, how old is the person for this ticket? 7. 7 should be a child. So we their ticket costs $5.50. The next person, we were checking the edge value. Remember, that's still important. We check that 12. That should be an adult ticket, which is $7.50. So we are now up to a total of $13. The next person is just any adult. We'll go with 49 as the age there. That should be another $7.50, which should take us to $20.50. The next one, we're going to do that edge value, which I believe is 55. If we forget, we can check, and indeed it is 55, which should be a senior ticket, and we were at 2050, so now we are at 21 plus 6 is 27. And the last one was somebody just over that, which will be another $6.50. So that will be 3350 if I did my math in my head correct. We have one more person to enter. I misremembered from the last lecture. I was thinking we needed 6, but we really only needed 5. But that's okay. We can add the last person in, and we'll just make them another adult, 33, and we get a total cost of $41. And I had been doing the math in my head. We had the 550 plus the 750, which gave us 13, plus another 750, which gave us $20.50. The 55 moved us up to $27. The next one was $33.50. Plus 50 is 34, plus 7 is 41. So it added correctly through here. So everything worked as expected. And that is an example of our deterministic loop. Now we did that by just saying how many people are in the party. Determine ahead of time how many people are we going to be working with, and then find out how old each person is and count the cost up. Now, one of the things I want to show here is one of the things we can do as a shorthand is we have this other operator called plus equals. This is a shorthand operator that allows us to take the variable on the left, the operand on the left, add it to the operand on the right, and store it back into the operand on the left. It's a shorthand for determining the value, so I don't have to type in the variable name twice. It's often enough that we want to do a calculation with the value of a variable and store it back in that same variable, that plus equals, minus equals, star equals for multiplication, and slash equals for division. They all exist within the language, so that we can take the value on the left, do some math with it against the number on the right, and store it back in the variable on the left. So just to show you that that doesn't change how this works, I will recompile. We have, whoops, I didn't compile. I hit Control C to kill the application. So that's why we got the error there. Now I'm going to rerun it. We're going to do 6 again, just so that we can see the same result. 7, 12, 49, 55, 77, and 33. At that point, we get the same value. With that said, we can actually save ourselves the need for this total price at all by simply doing plus equals on price itself. We're saving the amount of operations that need to be done by just incrementing or increasing the value of what we've spent so far by the new value. Getting rid of the need for this total cost variable at the top. Now do note, since I am not using total cost anymore, I want to print this out with price down here, because total cost is still 0. I declared it and never change it. Again, just as an oops, did it again. Just as to show you that it gives the same value, I recompile, rerun the program, use the same values as we did in the last running of the program, and we get the same value back. So this just kind of walks you through some thought processes that you might use um, with this calculation. Um, Deterministic loops are very common with calculations. When we do exponent math, which you'll get a chance to try in the homework, it's a similar thing. You would be taking some variable and doing some math against it with some other variable or value, and doing that in an incremental way so that you eventually wind up with your final result. Now, one of the things that, just as an extra piece of information, is sometimes we use minus minus here, which would decrease the value. We may initialize the variable to some predetermined value that's not 0. Like in this case, in theory, we could have initialized it to party size and said, while x is greater than 0, x minus minus. So we start with 6 for the first person, 5 for the second person, 4 for the third person, 3 for the fourth person, 2 for the fifth person, 1 for the sixth person, then it becomes 0 and drops out. Again, if we recompile, run this compile, and run it again. You have to compile between each time or the .class file doesn't get changed, so we think it's working because it ran with the previous version of the program, and give ourselves that false expectation that it's working. We do have to compile every time we make a change and save. 7, 12, 49, 55, 77, 33, we still get 41. So we've just looked at several different ways of doing the same thing, but in every case we were working with something deterministic. At this point on line 12, we know how many times we're going to have to loop. It's deterministic. So let's do a save as, and we'll call this movie tickets deterministic, so that I can hold on to it. And let's look at a non-deterministic way of working with this. Let's open, let's open the movie tickets as we had it, and instead of asking them how many people are in their party, let's let them continue to buy tickets until they say they are done. So what I'm going to do here is we're going to have the same way of doing the work inside the block, and we're still going to print out the result at the end, but we are going to loop in what we would call a non-deterministic way. Once we start looping, we determine after that point, sometime during the looping process, as we iterate over and over again, we'll determine then when we're done. So what I'm going to do is I am going to do a system.out.print for a prompting and ask a question. Do you need any more tickets? And then what I'm going to do is I am going to work with a string this time. We don't need party size, but we do need string. We'll call it more. And we will seed it with n for no. What we can do here is we can say more equals keyboard dot next. When we do next, we essentially say give me the next value as a string. So now what we're going to do is we'll say while more equals no. So what we're doing here is we're testing the value of the string more against the string n. As long as, y, as long as they say yes, we keep selling tickets. When we get no, we'll stop. How does this work? The syntax here is that as long as the Boolean operation in the arguments for the while loop are true, comma, we continue to iterate. So if the person says y here, then it will continue to iterate. So when they say n for no, it will stop. So if, for instance, a person started the first time and said, no, I don't need any more tickets, aside from them looking silly because they stood in line to buy tickets to buy none of them, if they said no, this would be false the first time through. Now, one of the things that may seem confusing right now is this use of the dot equals. I'm going to write a comment here to let you know. In Java, when we work with non-primitive types, we use dot equals to check the equality of two separate variables or values. I'm going to talk more about that in a minute, but remember our primitive types from our second lecture are our byte, our short, our int, our long, our float, double, Boolean, and char. String is not one of those. It is what we call a reference type. We're going to talk a lot more about that going forward, But for right now, if it's not a primitive type, we're going to use this dot equals. I'm going to talk about a little bit later in the next lecture about checking uh, the equality of primitive types through this same example. We're going to talk a little more about character values, cars, in our next lecture. So we're going to tweak this then. So what we've got here is the opportunity to ask the person how many tickets, I'm sorry, do you need more tickets? They'll give us an answer, Y or N, and then we'll go through this non-deterministic loop. One of the problems here is this next time it comes around the loop, it's not asking the question again. That's because it happened out here. So what you'll see a lot of people do is this. They'll copy that and drop it down at the bottom of their loop. And now the problem is solved. Just to show you the problem actually exists, let me comment that out. Let's compile. Do you need more tickets? Yes. How old is this person? 5. Oh, how old is the person for this ticket? I guess, well, I do need another one. That person's going to be 12. Oh, yeah, I still need 49, 55, 77, 33. Dang it. I don't know how to stop this. I have to kill it using the Control-C again. If I put my question again down here, we'll see that at least that solves our problem. Whoops. Recompiled. I wanted to run it. Do I need more tickets? Yes. This person is 5. Do I need more tickets? Yes. This person is 12. Do I need more tickets? Yes. This person is 49. Do I need more tickets? Yes. This person is 55. Do I need more tickets? Yes. This person is 77. Do I need more tickets? Yes. This person is 33. Do I need more tickets? No. The total cost of your tickets is $41. This works the way we expected it to. So let's let's look at some stuff. Just like we did with the for loop, I want to add some efficiencies in here. I want to look at a couple of things. One of the things that doesn't sit super well with me is the fact that I had to ask this question and pull the stuff off the keyboard in 2 different places. Whenever I'm repeating code in 2 different places, I think of that as sort of a red flag that I'm not doing something the best way possible. There are 2 solutions for this particular solution. One is we could initialize our loop to yes, and then we can remove asking ahead of time and assume that everyone who stands in line is indeed going to want additional, or is going to want at least one ticket. So when they come up, you ask, how old is the person for this ticket? They tell you. It goes to the end, do you need more tickets? And loops back around. That is using initialization to make sure that more is equal to the capital Y string ahead of time. If we compile, rerun, it asks how old the person is. 5, yes, I need more. 12, yes, I need more. 49, yes, I need more. 55, yes, I need more. 77, yes, I need more. 33, no, I don't need any more. And we still get the right solution. There is another generally preferred method for this, which is called a post-condition loop. So, going back to the notes section here, is there are two types of non-deterministic loops. Precondition, we check our Boolean operation before iterating, and post condition, where we check our Boolean operation after iterating. So what do we accomplish here? When we go back here, if I do the post condition, which allows me to grab this while and put it after the block, we simply put the word do, a different keyword up here as the header, that says do what's in here as long as more equals yes. We generally use a precondition loop for anything we want to do at least once, always once. If for sure we're going to want to iterate once, that's an indicator that we are talking about a post-condition loop. If we're not sure if we want to do it even once, then we do a precondition loop. In this case, we started with the precondition loop, but it required us to ask the question before looping, and then again during the loop. If you come into a conundrum like that where you feel like, well, I need to ask the question both on the outside and the inside in case I don't want to loop at all, chances are you probably want to ask the question in a different way. If we did this with a precondition loop, what we would probably do is, instead of asking if they need any more tickets, is something like, do you need tickets? Ask that, do the operation, ask them if they need more, and go through the process. In this case, I like the idea that that they're going to need at least one ticket, and doing this as a post condition loop, which is what we're going to do here. So we have a do, ask them how old the person is, go through the loop over and over again. And just to show you that doing the post condition does not require the initialization, I'm going to take that out, and we'll see that it will perform the operation one time. Whoops, I forgot my semicolon. Only headers don't need a semicolon at the end. The post condition, which is kind of a weird syntax here because we're kind of doing something at the end that applies to the block. That's why I put it on the same line. But remember, white space, line separators don't mean much in Java. I could put it on its own line afterwards, but it is customary to put it on the same line as the closing bracket. This is kind of a one-off thing in Java. So we do need the semicolon there. Oh, I didn't save. Let's save our work, recompile, rerun the program, and again, we will see that we're going to get the same results here. 12, 49, 55, 77, and 33. Just trying to make sure I remember all of the right values so that we know that we continue to see the same result. Seems pretty good. I think everything is good there. So what I am going to do now is I'm going to do this. I'm going to save it as movie tickets, non-deterministic, so that I can go back to my original, and I'm going to say file save as movie tickets, save, and I do want to replace, because I still have the non-deterministic version. I want to do a couple things here. So, one of the things that looping allows us to do is something called data protection. One of the problems that we have in this particular application is if someone were to mis-enter in the age. Let's say by deciding to enter in a negative number. That violates the spirit of data for age. So what I can do here is I can add a non-deterministic loop inside my deterministic loop. If going here, I say while age is less than 0. So what I've done here is at every iteration, I'm going to ask the person for the age of the ticket holder, capture that age, but if that age is less than 0, I'm going to go back so that they can get another shot at it. Now, for now, we're going to use an extra if statement. If age is less than 0, we're going to give them an error. System.out.println all ages must be at least 0. This theater charges for even infants. That way, we're conditionally showing an error. The difference between if and while is they're both checking the truth value of something if it's going to perform some operation once, while says perform the operation as long as we have true. So they're very similar, and we use the same kinds of conditions in both. But let's see how this changes what we've done. We resave our work. Oh, I forgot my semicolon again. Glad I caught myself before compiling. We come out here and we compile it again. And we run it. Gosh darn it, where's my, there it is. How many persons are in our party? 9. Oh, let's not do 9. I'm going to drop it from the 6 to just 3. You've seen how this works, and you're probably getting tired of me typing in tons of ages. So we'll just do a 5, a 12, and a 49. That should give us $20.50. So what we do is we get $20.50, and all is well. So, but if I do it where I accidentally say -5, what it says is all ages must be at least 0. Oh, I meant 5. And I can do this for each iteration. -12. Oh, I actually meant 12. 49. -49. No, I'm sorry, I meant 49. I still get the same price because it did this non-deterministic loop before the work of the outer deterministic loop. We can use the same thing out here for this party size, where I can say do while party size, oops, I don't know how I forgot my parenthesis there, is less than 0. And we'll throw in the same if party size is less than 0, system.out.println party size cannot be negative. That sounds a little less awkward than party size must be at least 0. Save that again. Recompile. And rerun it. How many are in your party? -3 people. Oh, my party size can't be 3. Negative. Let me do 3 people. How old is the first person? 5, 12, -49. Oh, I even fat fingered it more than that. Oh, all ages must be at least 0. Let's do 49. And how old is the person for this ticket? That was 49. We still get the 2050. Now we've protected our data. so that gives us another way of looking at this. Data protection is going to be something that's very important. We're going to be using it from here on out in this course, and you'll use it throughout your entire career as a programmer. You want to be able to determine whether people entered in valid data. There is a point that we're going to add on to in the next lecture. We're going to learn some really cool stuff um, about data types when we get more in depth into strings and we introduce our character type in a more distinct way. That's going to allow us to really add to the robustness of this program. At this point, we're still requiring the person to enter in a number. We can't yet handle if they don't type in a number, so we want to account for that at some point. So let's just keep that in mind. In our next lecture, we're going to add the ability to fix that into this program and beef this up even more. It's going to be a really a cool way to add that robustness, that professionalness to your development that is going to be valuable. With the time we have left, I do want to introduce one more idea. What we can use non-deterministic loops in a deterministic way, or what I mean by that is we can use while loops in a deterministic way, and we can use for loops in a non-deterministic way. These are a little thinking outside the box, but I like sometimes to introduce ways of thinking outside the box that help you to think creatively and look at things a little bit differently. For this for loop, what I can do is I can say while x is greater than 0, we're going to do some stuff. What we're going to do is, this looping thing in here like we were doing before. But at this point, x didn't have a value. In fact, it doesn't even exist. What we can do is we can say int x equals 0, create that initialization up at the top, and then at the bottom is I can do x plus plus here. What I have really done is I have taken the syntax of the for loop and separated it into 3 different statements throughout the program. I've done the exact same thing, and I meant to make this party size. But in this case, we don't know party size till here. So we will do x equals party size, initialize it property. And this wasn't a plus plus, it was a minus minus. My problem was I forgot for a second, that we had flipped it so that we would see the decrement version of the application. But I can flip this as well. But what we've done is we've taken this initialization piece and done it before the loop, which is the exact same way it worked before, right? Initialization occurs before looping. That's what we've just done. The end check condition is tested before each iteration. Here we go. We check it, we iterate. We check it, we iterate. Same thing. After the iteration, we change the value of the iterating variable. In this case, x. We drop it. So all we've done is we've just pulled that out. So it's a very straightforward way to see the exact same thing. It's more customary to do it in the for loop because it puts all of that stuff, everything we want to see, initialization, checking, incrementing, decrementing, however we iterate, all in one line, one place, really nice, concise language. But you'll see this other methodology does indeed work. Going back to recompile and rerunning when we say there are 3 in the party and we make them 5, 12, and 49, we're still getting our 2050. Likewise, we can use a for loop in a non-deterministic way. This is a lot less obvious, but just for the sake of seeing it, let's take our work and do it this way. If I say for age equals -1, age is less than 0, nothing, what I'm really doing is I'm taking age, which was already declared, right? Age is declared up here. So I don't have to put int age. It's already declared. You can't redeclare it. But I am initializing it here. I'm initializing age. And I'm initializing it at something that makes this true, because it's going to check that before every iteration. It's negative, therefore this is true. So it will ask this, then it will increment, decrement, whatever, based on what's here. I've put nothing there, so it's not going to do anything with age. What it's going to do is base it on whatever they typed in. It's going to do nothing at the end of the loop. So it's at the start of the next loop iteration, it's going to check, is age less than 0? If it is, it will go through this again. Let's see how that works. Again, it's less obvious, but this is helping you think outside the box. We recompile. I rerun it. How many persons are in my party? We're still going to make it the 3. But now, if I do this, and it did ask, because remember, age was -1, initialized to -1, checked it, it was good. Ask, I put in -5. It gives me the error, went back up to ask me again. I put in 5. It didn't do anything to age, increment, decrement, whatever, because I didn't give it anything to do. Just because these placeholders are here doesn't mean I have to do anything with them. If I had initialized age to -1 at the top, I could have left out what's on the left here and just had my condition in between 2 semicolons, and the for header becomes exactly the same as a while header, just with 2 semicolons. It's bizarre, it's syntactically weird, but it works, because simply what goes here is what happens before it loops the first time. What happens here is what it checks before looping each time, and this is what happens at the end of each loop. That's really what those are. What we call them and how we normally use them is the other way. So now I do the 5, the 12, and the 49, and I still get my 2050. This is a little outside the box, particularly this. But what I'm trying to show you is just um, sometimes there are ways to use constructs in a language that are different than the way they were intended. So don't spend a lot of time worrying about or thinking about what I did with the while as a deterministic loop or the for loop as a non-deterministic loop. I just want to expose you all to that as a way to think outside the box. So, in conclusion, for this lecture, just think about the things that we went over today in terms of our notes, which is that we have deterministic loops where we know the number of iterations before starting the loop, usually done with a for loop, and non-deterministic loops, which loops where the number of iterations is decided during the running of the program, which technically not deterministic ones can as well, but after the loop has been entered, and usually due to the activity of the user or data they enter. This is usually done with a while or do while loop. There are two types of non-deterministics. Precondition, we'll just say done with a while loop. It's technically usually, because we can do it with a for, but we're talking about, we usually do non-deterministics with while or do. Precondition is our while, postcondition is our do while. Again, the while, the while loop will execute 0 or more times. Our postcondition loop will execute 1 or more times. Hopefully this all makes sense, and you can use this on your next homework to do the work that needs to be done. And look next week for a new lecture that is going to introduce some other new concepts that is going to make what we've done here even more robust. If you have any questions, please contact me through Canvas, and take care.